Hi everyone, welcome and thank you for joining us for today's expert webinar titled Infrastructure as Code. I am Ria from SpringPeople. We are India's largest enterprise training provider and I will be your moderator for today's session. In today's session, we have Mr. Satish, who is a seasoned solution architect specializing in cloud computing with over 16 years of extensive experience in the IT industry. He brings a wealth of expertise in system and network administration, enterprise service management tools, system and application performance, capacity management, and DevOps solutions for enterprise applications. Satish possesses a comprehensive skill set spanning various domains within IT infrastructure and cloud computing. He is proficient in enterprise Linux, Red Hat OpenShift, and AWS solution architect, enabling him to design and deploy robust and scalable cloud environments. With expertise in Docker and Kubernetes, Terraform and Ansible, and App Dynamics and IBM APM, Satish excels in implementing automation and monitoring solutions to optimize performance and efficiency. Moreover, his proficiency in Prometheus and Grafana, problem resolution and troubleshooting further underscores his ability to tackle complex challenges and deliver high-quality solutions to clients. To all the participants, you can mention your questions in the chat box and it will be answered at the end of the session. Now, without further ado, I would like to invite Satish to start the session. Over to you, Satish.
Yeah, thank you. Thank you very much, Ria. Good evening, everyone, and greetings. Thanks for joining in. As Ria was mentioning, by now I have around 18 years of experience as a Satish Shettar, and I'm mainly into infrastructure, managed services, solutioning, designing, and other things. So without much further delay, so let's begin on a little bit of understanding what is this infrastructure as a code. I'd like to put as much light as possible in this next 1 hour. If required, we can also have further sessions in the upcoming days. Yeah. So we will go through a couple of points, like a little bit of an introduction. What is IaC, infrastructure as a code? We'll understand from one of the analogy point of view, like how does it looks like when I say infrastructure as a code. We'll understand what is the motive and what is the background. This is very important for us to understand why tools like Terraform is a reality today. And then what is IaC and how many tools are there? There are different type of tools used for different purposes with the IaC as a concept. And then some of the features, benefits, and the limitations. And then I'll open the forum for questions and also feedback. That's me. IaC as an analogy, infrastructure as a code. We have heard a lot of thing about 3D printers. Like, what is 3D printer? Now, if I have something designed at my system, it is go and build that particular product. You might have heard about first 3D printed building, first 3D printed device. So that is one of the thing. Logically, you draw something, physically things are happening. But here in Terraform, let's assume one of the analogy. You have a refrigerator at home and you are a user or kind of a family member at home, and there are a lot of servants available at home. And your wish list is at any point of time when you open the refrigerator, you should have some amount of eggs, some milk, and a carrot, loaf of bread at any given point of time that should be there. So that is your wish list, and somewhere you have written it or you have told it to someone. So whenever you consume those things, depending on the state of that refrigerator, out of 10 eggs, if you have consumed 4, it will become 6, right? So the people who have got the instruction from you, they will make sure they check that particular list of things which is provided by you. If there is any deviation to that, they will make sure that instructions are always met. They will bring additional things, whatever is missing. Like if you have consumed 4 eggs, they'll bring those 4 eggs, and they'll make sure at any given point of time, the list of things what you mentioned is maintained. So they'll do it anything. They'll either get it from their farm, they'll either get it from the shop. So the objective is to make sure that particular list of items are always there. So this is one way of looking at it in my day-to-day life, how it looks like. And when you go to the restaurant and when you go to an order, you may tell them what are the dishes you would like to have and what are the customizations you want to have. You may have you might have asked them 10 things, right from the welcome drink or beverage, and then uh, snacks, and then a dinner and main course, and then a dessert. So they know which particular food they would like to serve first and which one should be the last. So they doesn't bring the dessert at the first time, they'll bring the dessert at the last time. So if you instruct them, these are the list of things I need, they know the sequence, when this should be done, in which order it should be done, what is the dependency, what are the things it should be done as per the actual culture. You know, of course some people eat sweet in the beginning and some people do it in the last, but according to their practice, what should be done at the first and what should be done at the last, depending on that, they will start serving you. So these are the two things I can think of what is infrastructure as a code in our day-to-day life. Let's understand what makes Terraform kind of a tool reality today. So what was the pain? What was the challenge industry was having? Now, industry had a lot of expert, and trust me, it has been always a big challenge to find the skilled resource for enterprises, for organizations, for the people who are ready to do the business using IT as a catalyst. So, and also time and results are very important. Getting a result within a very short time is very important. So, experts have been having a desire to find something which is automation. Like, need of automation is always there, right from manufacturing the car, right from chopping the vegetable at home, you take it everywhere. Automation is something we desire. Somebody want to drive a car by sitting at home, right? You have seen those things in a James Bond movie, all those things. Now, IT industry has been having a lot of automation requirement because it is very difficult to get the skilled resource, and if you get one also, it is difficult to make them stick to one position for a longer duration. Now, as I had this desire of having the automation, the approach and practice was way having a lot of diversities. Some people will do automation in shell scripting, some people will do automation in Python, some people will do the automation in Perl. When they change their position because of the attrition or because of the promotion, the person who comes to fill or backfill his position, he has his own challenges. He won't be able to understand the logic. He will be good at some other code. That automation piece will go for a back burner, and he will introduce his own way of looking at automation. It will take an additional effort or redundant effort, all those things which will make things different approach and practice. And having shell script will not help you across multiple tools. It may help you up to the operating system level. It may not help you at the database level. It may not help you at installing the SAP and customizing that, all those things. Complexity and scale is also one of the matter. You cannot do the automation at a very large scale. So that was one of the challenge. And consistency. When you do the automation in organization one of one particular business unit, the other business unit requirement changes because their way of looking at things, data, and application logic differs in terms of security, in terms of various other factors. And moving the automation from one particular business unit to another business unit, one client to another client, it was not so agile, it was not scalable. So the having all these things as a challenge for last couple of decades, I would say, a new era which is cloud computing and API based functions and tools have brought really a lot of hope, and also it made a path for tools like infrastructure as code to be a reality. Immutable infrastructure where you don't have to really tweak anything. When you take a car to service center, what they'll do, if there is a dent in the vehicle, they'll not remove the dent, they'll just replace the spare part, right? So I'll talk more about this in immutable infrastructure in the upcoming slide. Cloud computing has really turned the things to get the resources quickly whenever the organizations is looking for. Version control and collaboration, when multiple people are trying to work on a same objective, version controlling and collaboration like Git has its own way of enabling the system and business. DevOps way of doing automation. So first the Terraform should run, and then Ansible should run, and then it should be CI/CD way of doing it. So all these things were really helping or adding the environment for tools like Terraform to be a reality. So otherwise, this collaboration, having absence of any one tool out of this 5 would have created a lot of vacuum to have such tools in reality today. Gartner says, okay, Terraform is one of such tool which is way far better than any other tool when it comes to infrastructure as a code. Terraform is a HashiCorp tool, and this survey was made somewhere in 2021, and Gartner has said a lot of thing to be changed the way automation industry was looking like, and it has really picked up right from 2000 whatever time it has been introduced, and many people are adopting this because consistency is one thing which would be very much required for this. I can start one particular resource in cloud. Similar to me, 10 other people can also start the same resource, but the way we provision that resource may change. The consistency matters. And when it comes to business, they need this consistency across different environments. When I say different environments, it's like dev, non-prod, pre-prod, UAT, XUAT, DR, production, all those things should have similar set of resources and those stacks, whatever we provision with the help of this particular infrastructure as a code tool. Now, what is this infrastructure as a code? Now, there are a lot of such tools available in the market, but when it comes to infrastructure as a code, it has a actual objective. These tools like Ansible and Terraform are completely emerged due to the increased complexity of managing the IT infrastructure, because sometimes you have application workloads running in AWS, couple of applications are running in Azure, some of them are running in on-premises because you need more secure. So the need for the automation in the modern software development and operations is quite demanding. And some of the factors like this immutable cloud computing, all those things are helping us a lot. Okay, now instead of doing things manually, like one by one, you know, going to AWS portal and starting a VPC and starting an AWS instances and then Beanstalk and all those, doing this all those things manually, you can easily write a code and you can run it with the help of that API call. AWS will understand and it will get the instruction and it will make sure those resources are provisioned for you. Of course, authentication is there all the time. That we will talk it in a different session. But Terraform or infrastructure as a code tool is going to initiate one API calls with the way of how these things should be provisioned, in which sequence, and who should talk to whom, at what phase. All those things will be pushed to that particular AWS environment or Google environment or Kubernetes environment. With this configuration, those resources will be created, including the infrastructure specification, which makes easy and also simple to move it across one environment to another environment by distributing it across the configurations. We usually call it as promoting. If it is working in dev, let's promote this to the next version, next environment, something like that. When you promote this particular configuration to the next environment without any challenge, it will get the similar setup created in the next environment. It could be UAT or it could be test environment or something. The best way is your infrastructure is everything is codified, and once it is codified, you can easily put it into version control management system, and you can document it, and you can understand how this how this document has been evolved over the time. So when you started around 2 years back, what was the set of instruction? And as you go on every month, every week, every quarter, how this document has been adding or deprecating the changes to that particular setup. Okay. Version control like Git. When you integrate or when you start associating this infrastructure code with Git, you can easily find out who did what at what time. And also, if there is a provision, you'll understand what is the requirement, what was the change number, what was the incident, why this was added, and all those things. Of course, version control has its own significance. Whenever the team members are making any changes, it has to be brought back to the lead to approve or reject, to merge that particular code. Accordingly, your environment will get either adding the additional resources or removing them or enhancing them, all those things. You can also make this infrastructure as a code as modular component. So when you, of course, there are modules available in Terraform. In other tools also, there are certain provisions available. You can, I would like to put it like this. If there is a certain set of stack which needs to be provisioned again and again, you can create those things as a module and you can store it in your own code to call that particular module rather than writing it every time to each business unit or each infrastructure or to each account, something like that. Where it is really adding a value, I tell you guys one particular truth here. Let's not take it as a truth. Business always needs a solution, and the solution is something we call it as a business application logic. When the business person explains something, this is how I do the business, this is how I need the data, this is how I need the application to be, it is the developer who understands the requirement and who initiates writing the logic to meet that business requirement. In between business and developers, people like us who are managing the infrastructure play a lot of crucial role to start those infrastructures for them. And when we do it, because of the additional layer what we are creating in between the business people and developer, it adds a lot of latency, it adds a lot of additional process, which everything together brings a lot of additional time to get the solution or solution for the business, I would like to say. So this infrastructure as a code, if developer understands and creates the code to provision the resources, it could be server, it could be operating system, it could be network, storage, or anything in any way of combination, putting those things as a stack to deploy their application logic. They don't have to really wait for operations guys. I'm not saying operations guys, infrastructure guys. So developer would always say, I need one machine with so and so configuration, with so and so database, application server, web server. So these things are taken by infrastructure team and they are provisioning those things. But infrastructure as a code is eliminating that particular layer, whereas developer can write the code for themselves and they can just run it. Their infrastructure will be ready and they can start working on deploying the application. Okay, now it's high level descriptive coding. There is something called as declarative and imperative. Declarative is something, the moment you declare your wish in the code, it will make sure that particular resource or service or infrastructure is provisioned. Some of the leading tools in infrastructure as a code, like Terraform is one of the popular. OpenTofu is an open source of Terraform. Earlier Terraform itself was a open source code. Now OpenTofu is something they introduced as mainly for the open source, and they are moving away with enterprise version of Terraform and other things. TerraGrunt is one of their own uh, version. When you want to make the detailed configuration complex level, you can go for TerraGrunt. AWS has their own proprietary infrastructure as a code, which we know it as CloudFormation. You can write code very much similar to Terraform, like using their own way of YAML code, yet another markup language code. And they have their own libraries, they have their own parameters. Accordingly, you can write a CloudFormation template. Azure has their own way of doing it with ARM templates. Google has CDM. So, but the problem, I don't say a problem, the limitation of CloudFormation is within AWS. Azure ARM is within Azure. Google CDM is within Google. So when you have the enterprise who's having all these cloud environment for their application and day in day out provisioning, of course you need something which is common across all these things. Like Terraform works very much with AWS, Azure, Kubernetes, OpenShift, all those things. You can write a code and you can make Terraform single template can work with multi-cloud environment. That's where Terraform stands out from the crowd and becomes one of the easy tool to go with. Okay, so its main purpose is to automate the infrastructure provisioning and management. Of course, for developers, infrastructure tools, when the account is very big, when the client or when the organization is very big, of course they will have a separate team for infrastructure, because that comes with a lot of other things like capacity management, governance, accountability, and all those things. But in the smaller organizations, where smaller teams work in a silos, developers will be able to easily adopt this particular Terraform or infrastructure as a code way of looking at things, and they can reduce a lot of manual provisioning and management. Cost, of course, a lot of cost can be controlled by reducing the time and reducing the risk. How do we reduce the risk? We won't be provisioning anything more than what is required, and also Whenever there is any change required, we will be replacing those things with having immutable infrastructure. And by having adopting this infrastructure as a code, you will be very quick to the market. You can easily be ready to go to the market and get the opportunity to grab whatever it is there as an opportunity. DevOps team, of course, it will help them create a lot of pipelines and manage the single pipeline across 3 to 4 different environments, which will be consistent across multiple environments. Software delivery lifecycle will be very effective by having this infrastructure code. The lifecycle will be able to see those changes in a very quick manner rather than waiting for a lot of other people and collaboration in place. Gartner had 4 major predictions that's in front of you. Like by 2025, 70% of the organization will have such kind of tool for infrastructure automation, because that's how the complexity is getting becoming. And by 2025, 50% of the enterprises will develop the skills for this infrastructure automation to manage their hybrid and multi-cloud platforms. Like, of course, you can easily see nowadays, application is there in AWS, database is there in Microsoft Azure, and some of the uh, critical things, artifacts and other things are available in on-premises. Of course, it has become a hybrid as well as multi-cloud platform. So one person having knowledge about all these things is currently in the demand. But one person having knowledge across all these things should be able to turn things very quickly, needs a tool like infrastructure as a code, which is going to be very prerequisite kind of skill in next 1 or 2 years. Okay. By 2027, 35% of the workload will not be optimal. So when I was adopting the cloud in 2015, they were saying around 70 plus percentage of the application are not compatible to move to cloud. Now they are saying 2022 is 55%, which is 7 years they have reduced around 30%. And now by 2025 2027, 35% applications will not be optimal. That means some of them will get retired, some of them will get re-architected, refactored, recoded. All those things will happen to meet the way how cloud works. When the application goes through the transition, of course it is going to get considered for infrastructure as a code way of looking at it. Okay. By 2025, newly procured on-prem premise. So what he meant by the last point is, whatever CPU and storage is being consumed, it will start appearing like a service, not like a component. So which is kind of an increase from last 2021 to 2025 in 10% difference. How to choose the right IaC, infrastructure as a code? There are multiple type of tools. So when it comes to your way of looking at things, do you want things to be declarative or imperative? So imperative means you do things one by one. Declarative is something you just define things, whatever it is. The tool will take care and it will understand what needs to be done. It doesn't need much details. Sometimes you just have to mention 3 to 4 parameters instead of 15 to 20, because there is something called as mandatory input, something called as optional, or kind of liberal way of mentioning things. It is declarative and imperative. So declarative is dominant and idempotent. Dominant means it takes the control over that particular cloud provisioning, cloud service provider, and it is idempotent. Idempotent means when I start the configuration, as I need 5 instances of X configuration, 2 instances with Y configuration, and when I change that Y configuration into two different configuration with Z, and when I run the code again, it will not make any harm to those X configuration. That is called idempotent. You can run the code 10 times. If the code and the state of the infrastructure is same, it is not going to harm, or it is not going to change. It is not going to recreate. So that is called idempotent. One of the best possible approach, or one of the best possible things is, you can, there is something called as state, Terraform state. So idempotent understands what is the current state and also what needs to be done. If it finds the state is very much similar, it doesn't go and make any changes. But whereas imperative makes you to do all these things step by step with the help of command or manual wizard, or doing things one by one. It needs a very good skill, understanding of that particular tool, and also you need to be good at certain things like Ruby, Python, and Golang, all those things. Of course, infrastructure as a code also needs you some coding skills, but it doesn't need oops level of coding skills. At a very high level, YAML scripting should be helpful. Large infrastructure need such tools, otherwise it becomes very difficult to manage with the existing resource and a skilled resource. It's the same thing what I spoke. When imperative is something, the system is stupid, you are guiding it step by step. When the declarative, the system is smart, you are just guiding them what needs to be done, what need not to be done, something like that. The second point is provisioning and configuration management. Infrastructure as a code makes your life easy and to provision the resource, whereas configuration as a management, post the resource provisioning, you will choose one more tool like Ansible. What is the configuration needs to be done? Like once the computer is started, VM is started, you need to install certain additional binaries, you need to install additional environments, software development kits, you want to harden it. So all those things comes at configuration management. So picking up a Terraform for provisioning, picking up an Ansible for configuration would be the best approach, and that's most of the people are doing it. Okay. So provisioning, Terraform does setting up an infrastructure, whereas Ansible kind of tools will do installing the software and configuring it particular application or database, all those things. There are some tools which can perform both the tasks. Like Ansible, I'm not saying it is not good for provisioning. It is good, but you have to write the code accordingly so that provisioning and configuration management both can be configured. It needs deep down L3, L4 level of skills in Ansible, but of course, people have two separate tools for infrastructure as well as configuration management. Mutable and immutable. So what do you mean by immutable? So there are certain tools or setups, when you provision, you can easily go and tweak those things to meet the business requirement. But in the immutable, what happens, if you need a change, you cannot go and change the existing one. You need to change the source code, and you need to replace the version of the existing component. Say for example, I have an EC2 or in one of the VM which has 2 CPU and 4 GB RAM. I'd like to increase it. I'm not going to make change on that particular VM by shutting it down or by increasing it. What I'll do, I'll mention the change in the Terraform code and I'll run it. In the next run, it will replace it with the new system. So immutable is something, whatever change you would like to bring it, you will bring it with additional or added version of the new module rather than tweaking it. Okay. As I said, it cannot be changed once it is deployed. It is always, you can easily roll back, but when you want to change, when you want to have some enhancement, you can always introduce the new version of it. So in the larger environment, immutable is one of the best and most preferred. So this is how the infrastructure works. Infrastructure as a code works. Developer writes the code. It has scripts, templates, and policies. And this also has a tightly coupled with version control. And as soon as it meets the approval or whatever it is at this phase, it will be pushed to the right kind of tool, whether it is an Ansible or Terraform, Chef, Puppet, AWS CloudFormation, whatever it is. Based on that, that infrastructure will be provisioned. So what I'd like to say here, the developer or the infrastructure person, anybody who's writing the code will have an additional layer, and these tools are acting like an additional layer in between actual infrastructure and the actual user. That is what the biggest gap earlier days, because the person whom I replace, I don't know the Perl, he was knowing the Python, so that was the gap. Now these tools are helping us bridge that particular gap, which is making the life easy for actual business people, because they don't have to really bother when the person leaves or get promotes. The next person will be able to easily understand, and they don't have to write a very huge or big logics. It's all very straightforward, and one who knows English will be able to easily understand these codes. Either a developer or an infrastructure person is going to write infrastructure code, and he's going to plan, and in the plan he'll come to know what is working, what is breaking, what is enhancing, what is deprecating, and then by looking at the result, he can revisit the code to tweak it, or he can choose to apply. What happens when he chooses to apply, depending on what infrastructure you want to modify or provision, it will pick that particular plugin kind of thing, provider we call it as, and that provider has the detailed instruction what needs to be started, in which sequence, what is the dependency, all those things. Okay, and these providers are either written by the service provider, like AWS writes the provider and gives it to Terraform to manage in their repository, or there are third party vendors who will write it, and it has a provision also for anybody to write their own providers. Some of the features, like time consuming, is one of the very biggest threat for businesses, because whenever there is an additional time, they lose the opportunity, and business doesn't like losing the opportunity. And you know, infrastructure as a code will help you move faster your solution to the market, and very less consistency issues, lower drifts. That means whenever the person is replaced by any other person, or you know, the individual who is managing the infrastructure, if there is a change in the people, you don't have to really worry much. You know, it will be easily taken care by the newly adopted people, or uh, new resources who are replacing them. Having infrastructure makes your uh, entire software development lifecycle easy and lower cost, because open source and other things, and improved ROI, return of investment. Protection against churn, so you don't have to really bother about getting uh, identifying those bugs and other things. Infrastructure related complications, gaps. So we have some of the limitations. Of course, Terraform is not going to do everything for you, because when you are picking up the tool, you need to mind these limitations a lot. what are these limitations? Now, it brings a lot of complexity, and you have to define all these things, maintain all these conventions, and it has its own standards of adding additional layer of uh, the code in between your application. Okay. Okay. Now, tooling gaps and feature gap. Whenever there is an service provider, for example, I'm using Terraform with my AWS environment. You want to use this Terraform to provision something new, which is newly introduced by AWS, but immediately you may not have that particular feature available. Say, for example, AWS has introduced something new called SageMaker for MI, AI and ML based service. You may have that feature gap in the tool. You, first of all, you should have the skilled person who knows AWS plus Terraform. I cannot just bring Terraform's person and I can ask them to start managing my AWS environment. It should be the person who knows the AWS plus Terraform. Then only it will help me manage my infrastructure. Otherwise, if the person knows Terraform very well, and if he don't know AWS, he will really create blunder. He's going to mess things up. So appropriate skilled people is one of the complexity. And configuration drift. If there is any change, if there is any issue, you may tend to lose the data. You may tend to lose the data. Data is the biggest problem. That's why you need to classify those things, what needs to be maintained in which order, what needs to be kept in silos, which doesn't need much automation or such kind of things. Coding language dependency comes to a picture when you don't have the feature. Say, for example, as I was telling, uh, we had certain issues. AWS introduced one particular service, and the people who are already wanted to use it, they wanted to use it, but that feature is not available in the AWS provider. When I say provider, it's an additional uh, component. This is what I was talking about. So this is a provider which understands from the code, and it will help how that particular service to be provisioned in the actual AWS. So now that coding language dependency comes when the feature is not there. You should be good in that particular coding language. Terraform is written in Golang. Other tools are similarly written in other codes like Python and other things. You should be able to write that particular module, or so that you can provision that, which is not going to be approved, and those things have complications and limitations are there. Security assessment. Your legacy security tools or process might not help to be enough for the infrastructure as a code world. Coding language. Okay. As I was security assessment product, right? Okay. I missed it. I got deviated from the cell phone. Sorry. Um, you may have certain security practices to manage your previous environment, but having this infrastructure as a code, you might be manually checking all these things. This kind of things might make some challenges. Of course, it has to go through that life cycle. Manual checking is kind of a lot of confidence building step, but it may take multiple iterations as you have multiple stacks. And considering this infrastructure as a tool, as a code tool for this security checks might be a little challenging in the beginning. Monitoring, Whenever you want to monitor this CI/CD to provision the infrastructure, it might be little challenging whether it is successful or not, and such kind of a conditions you might have to think before you adopt this infrastructure as a code to be monitored by CI/CD pipeline for its own different stages. Now, having these limitations, service providers are always working to fix those things. But as the word goes, the new kind of trend, new kind of uh, technologies, processes, and those things are always there. Those limitations might be addressed. The new limitations might come because of the over the last 10 years when this cloud got introduced. Really, the IT word has diversified to the sky. I mean, so you need to be very careful when you are picking these things by keeping your 1 year, 3 year, and 5 year strategy, so that you don't have to really go through the pain of changing the infrastructure as a code in the later days, which would impact a lot of people, including the business. So those are certain things. It's not purely about Terraform. Terraform, I just wanted to bring a couple of examples, but as an infrastructure as a code, how it is helping the entire IT world and business world. So that's where I wanted to throw some light on. Hope that kind of information is going to help you when you look at this infrastructure as a code in your learning or adopting phase of your career. That's all I have for today. And if you have any queries as such, if you have any questions, kindly put it in the question section. I'd be very happy to address those questions. Okay, over to you, Rhea.
Great. Thank you, Mr. Satish, for your invaluable insights on technology. I'm sure it was certainly a very informative session for all. And like Satish has already mentioned, we will open the forum to answer questions that we have received during the session. Okay, over
Okay,
to you,
let's wait
Satish.
for them. Let's wait if they have any questions around. One of the common questions which I got: what is the difference between Ansible and what is the difference between Terraform? Now, Ansible and Terraform both are open source. Both have their own pros and cons. Now, Terraform is a declarative. It's a infrastructure provisioning primary objective of the tool. When it comes to Terraform, it's a declarative. I can write EC2 first and I can write VPC later. But when I run the script, tool understands VPC should be started first and then the EC2. It understands the logic and it goes with the flow. So that is, we call it as dependency mapping and provisioning. Whereas Ansible is a procedural. It will go with the code flow, and accordingly the both difference tool differs. I'm not saying Ansible is not possible to do it, but you have to put a lot of effort to write the code in that manner, lot of modular based and conditions and calling them and all those things. You have to put a lot of effort, and it should be easy for others to follow in your absence. So that kind of things makes difference. Terraform has certain thing called state, which is missing in Ansible. Whenever you run anything, any configuration tool, it creates a state, and when you try to run it again, it compares the next execution with the states, and it will say, hey, this particular resource is already available, I should not be doing this again, and it will say no changes. So like that, Terraform has something called a state, which Ansible is not having. But when it comes to similarities, both are template based, both are open source. Very best thing is both are agentless. You don't have to install an agent on the remote machine. It works agentless. So that's why most of the people have Terraform for infrastructure provisioning, Ansible for configuration management. This is one of the most widely or asked questions when we go through certain tools, presenting or debating across. Okay. Anybody has any other anything to say? Not only questions. If you want, you can add also. Terraform can also do the scripting task before doing the actual. Yes, you can call the external script to run and get some objectives and then perform the rest of the Terraform instructions execution. Terraform can trigger a third-party scripts. Terraform can trigger Ansible in between or end of the Terraform execution. So you can mention some wait time, sleep time, and you can expect some outputs. What is the output it should get? If it is getting this particular output, it should be able to continue. If it is not this output, it should fail or it should stop there. Something like that you can integrate, and you can make your such script to run either beginning or in between or later part of the Terraform configuration execution. I hope that helped you understand, Chirag. Okay, any other questions? Shall I take the silence as no? Okay, great. Thank you very much for your time and being here. It's my privilege to present these things to you. I hope that would help in your learning curve or understanding these technologies from even a nearer point of view. Thanks for your time again. Over to you, Ria.
Thank you, Satish, and thank you, everyone. We appreciate you being here. We shall be sending out the webinar recording to all you participants soon. I request you to kindly provide feedbacks before signing off, which will help us improve the quality of our future events. Thanks again for joining us
Yep.
today.
Kindly don't forget to give the feedback. That's kind
Correct.
of a lot of enthusiasm, which will bring me to prepare even better. Give a constructive
Absolutely.
feedback. It is very valuable for me. Thank you. Have a nice time ahead.
Absolutely.
Bye.
So, like Satish said, it is very important for us to improve the quality, and we can prepare more better next time. So, thank you again for joining us today, everyone. I'm signing off on behalf of Team Spring People. Hope to see you again for our next expert webinar. Thank you.